Today we will discuss about counter. The counter is a very important point in mid-range and advanced microcontroller. Today we will discuss about the basics of the timer. A timer is a specialized type of clock which is used to measure time intervals. Now there can be two types of timers. Okay, a timer that counts from 0 upwards for measuring the time elapsed is a timer, and the example is stopwatch. Then it is a device that counts down from a specified time interval and used to generate a time delay. That is also a timer, which is, and the example is hourglass. So first let us see the timer with up counter. Consider that there is a register which can have maximum value of FFX. So we are considering an 8-bit microcontroller. For 8-bit microcontroller, the register size is 8-bit, and with 8-bit you can have maximum of 255 decimal or FFX. FFX is equal to 255 decimal. Now also consider that the initial value of the register is equal to 0. The maximum value it can go up to 255, but the initial value is 0. Now we are applying the clock to this register. So how many clocks will require to reach 255 from 0 to FFX? That is FF minus 0, that is 255 clocks. So with 255 clocks, we will be reaching the maximum value, that is FFX. Now reaching the max value will not cause the interrupt. Before going to the interrupt, let us consider that instead of 0 hex, the initial value should not be 0 hex every time. Okay, it can be any other value as well. For generalized thing, we consider XY hex. Then how many clocks are required to reach FFX? FF minus XY hex clocks are required to reach FFX, that is the maximum value. Once the value reaches FFX and still more clocks are coming, the register cannot accommodate any more incremented value because its capacity is up to 255. After reaching FFX, if one more clock comes, then the register overflows and goes to 0. This particular event is captured and a tick is generated and a flag is set. That is the interrupt flag due to the timer. So this is your timer output. This is an photo. This is a photo of the timer with up counter. So you can see there we have a clock generator from where the clocks are coming. We have the timer, and inside the timer we have a register. In this register we set our initial value, and whenever one clock comes, this register value gets incremented by 1. So eventually it will reach FFX, that is the maximum value 255, and after that when one more clock comes to this circuit, then it will be overflowing, and when it will overflow, it will set a flag that is known as interrupt flag due to timer. So this is the concept of timer with up counter. So what is the count to overflow? The count to overflow is maximum value of the register. Maximum value of the register in this case is 255 minus value inserted in the register. What is the value inserted in the register? It is your value. It can be 0, it can be 30, it can be 40, or whatever it is, plus value of 1. Why? Because to overflow you need one more clock. Okay. So timer with down counter, it is also almost the same, but in this case what happens, with the application of clock, your register value gets decremented by 1. In earlier case, register value was getting incremented by 1. In this case, register value is getting decremented by 1. Okay. So since it is decrementing, eventually it will reach 0. But reaching 0 will not harm anything. When you apply one more clock after reaching the 0, then it will overflow. Okay, and that event is captured, and that is your timer output. So for this case, count to overflow will be value inserted in the register, okay, plus the value of 1. Now since the value inserted in the register is quite high, so you can consider as count to overflow is almost equal to value inserted in the register. You can discard the value of 1. Now if we consider our PIC 16F877A board that is present in our lab, which works with 20 MHz external crystal. Now what do we mean by 20 MHz? 20 MHz is the clock frequency. That means 20 into 10 to the power 6 events. 20 into the power 10, 6, 20 into 10 to the power 6 events, that is on off cycle, happens only in 1 second. Okay. So time taken for one clock cycle, to get the time taken for one clock cycle, you need to inverse the frequency. Okay. In this case, it will be 1 by 20 megahertz, which will give 0.05 into 10 to the power minus 6 second. That means one clock takes only 0.05 into 10 to the power minus 6 seconds time. But the timer unit inside the microcontroller does not get this frequency directly. Timer gets this frequency divided by 4. That is known as machine cycle. So if we say that FOSC, that is the oscillator frequency or the crystal frequency is 20 megahertz, then the frequency to timer is divided by 4, that is 20 divided by 4 is equal to 5 megahertz. And if I want to get the time period of that, so we have to inverse this. So T is equals to 1 by FOSC divided by 4, that is T is equals to 1 by 5 megahertz. FOSC divided by 4 is equal to 5 megahertz. T is equal to 1 by 5 megahertz, that is T is equal to 0. microseconds. So one count of the timer will take 0.2 microsecond. That means from 0 to 1, to count this much value, the timer will take only 0.2 microseconds. So if you want to count C, then the timer will take C into 0.2 microseconds. Okay. Now calculating C value, okay, calculating the C value. Now counter to overflow required to achieve a given timer interval. Okay, calculating C value, count to overflow, that is required to achieve a given timer interval. Let us take an example. That we want to produce a time interval of 1 second. We want to produce a time interval of 1 second. We want a delay. We want a delay of 1 second. Here we know the value of T. What is the value of T? Already we have seen, that is 0.2 microsecond. But C is unknown. So how to get that C? Required time delay is equals to 1 second. 0.2 microsecond comes from how many count? One count, right? 0.2 microsecond comes from one count. Then 1 second will come from how many counts? Then 1 second will need 1 divided by 0.2 into 10 to the power minus 6. Okay, the unit should be same. The count value is obtained. C is the count value, that is T required by T, unit of time for T required, and T should be same, that is already told. Okay, and in this case it is C is equals to 1 divided by 0.2 into 10 to the power minus 6, that is 5 into 10 to the power 6. Okay, so what will be the count required to have a delay of 1 second? That is 5 into 10 to the power 6. Now for down counter, count to overflow is equals to value inserted in the register plus value of 1. Once the register is set to the suitable value, in this case 5 into 10 to the power 6, and minus 1 due to the 1 clock, the controller will interrupt the CPU once every second and jump into the interrupt service routine. Okay, so that means what? Our register value has to be 5 into 10 to the power 6. It is 5 into 10 to the power 6 minus value of 1, but we can discard to the value of 1 because 5 into 10 to the power 6 is quite a large value considered to 1. Now, the timer can also have prescaler and postscaler. Okay, so here you can see the prescaler and here you have the postscaler, and inside that you have the timer register. This is usually 8-bit or 16-bit. Here we are considering 8-bit, that is the 255 was the maximum value or FFX was the maximum value. Now what is prescaler? Prescaler is nothing but a frequency divider. Okay, before reaching to this timer, the prescaler divides the frequency. Already the oscillator frequency is divided by 4. Now the prescaler divides it again further. Okay. Now if the prescaler is set 1:2 and this is the clock cycle, then the frequency will be divided by 1/2. If it is 1:4, frequency will be divided by 1/4. If it is 1:8, then the frequency will be divided by 8. So this is actually one method through which the timer clock frequency is getting divided. And what are the values for divider? That is 2, 4, 8, 16, etc. Okay. Now let us take the older example that we have already seen, that if I want to get a delay of 1 second, okay, if I want to get a delay of 1 second, how many times the timer should count? Okay, how many times the timer should count? So for that we have already found that it has to count C is equal to 5 into 10 to the power 6. Meaning what? The timer register has to have a value of 5 into 10 to the power 6. So it will start counting from 5 into 10 to the power 6. It will go down, 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 and finally it will reach 0. And when it reaches 0, after that one more clock is required. And when it is done, you have got 1 second delay. Okay. Now if you need 2 seconds delay, what you need to do? It's simple. You just multiply the value of C with 2. So that will be 10 into 10 to the power 6. Right? That's quite a high value. Now here here the prescaler plays the role. Using the prescaler, the frequency is further divided. Say here we consider by 2. It can be by 4, it can be by 8, or it can be by 16. Okay. Therefore, frequency that eventually goes to the timer is equals to F oscillator divided by 4 and again divided by 2. Divided by 4 due to machine cycle that we have already seen, and again 2 due to the prescaler. So what will be the frequency that is going to the timer? That is your 2.5 megahertz. Therefore, what will be the time period? The time period will be 1 by 2.5 megahertz, that is equals to 0.4 microsecond. If t is equal to 0.4 microsecond and c is equal to 5 into 10 to the power 6, what will be the total delay? The total delay is here. The total delay is t required. So t required is equals to c into t. C into t, that is 5 into 10 to the power 6 into 0.4 into 10 to the power minus 6, that is equals to 2 seconds. Okay. So meaning what? Setting the prescaler value to 1:2 is nothing but doubling the register value. If I wanted to get this 2-second delay and without the prescaler, the C value should have been this 5 into 10 to the power 6 multiplied by 2. But in this case, when we have applied the prescaler, we can see that with 5 into 10 to the power 6 value only, we are able to achieve the 2 seconds of delay. Okay. So dividing the input clock frequency is same as multiplying the register value by the same amount. Hence what? By using this method, the timer register is essentially get multiplied by n, where n is the value set by the prescaler. Now there is a postscaler. Postscaler is also same like prescaler. It is also a divider, but it is a post divider. Okay. Now when interrupt happens, whenever the timer overflows, the interrupt happens. But postscaler controls that. Postscaler says, no, not for only one overflow I will not give you the interrupt. It can be 2, it can be 4. Okay. So if the postscaler is set to 1:2, then the timer has to overflow 2 times to generate the interrupt flag. Okay. So if the postscaler is set to 1:2, then the timer has to overflow 2 times. Okay. So only one time overflow will not generate the interrupt flag. In the same manner, if the postscaler is set to 1:4, then the timer has to overflow 4 times to generate the interrupt flag. So in this manner, if n is your prescaler value and m is your postscaler value, then how many counts you require to overflow the register for an up counter? That is C equal to n. N is the prescaler value into maximum register value. If it is 8-bit, then that will be 255 minus the value you have set in the register plus value of 1 inside the bracket into or multiplied by m. And for the down counter, it is much more simpler. The count will be n, that is the prescaler value, multiplied by m, that is the postscaler value, and whatever value you have set inside the register plus value of 1. So this is your concept of prescaler and postscaler. Now there can be some cases when C value is too large to accommodate within the available register, because the register has a limited size, 8-bit, 255. Okay, in case of 8-bit it is 255. But what is the value we need to put inside the register that we have found? That is 5 into 10 to the power 6. That is much larger than 255. In this case, what we need to do, that we will see in an example. That you are seeing that an ISR has been written, void interrupt ISR. First we are checking that if timer 0 interrupt is enabled and timer 0 interrupt flag has been generated, then we are coming inside the loop and we are increasing counter by 1. The initial value of the counter has to be taken as 0 or any other value. But what is our requirement? Our requirement is that whenever the interrupt happens, I want to toggle one LED. But since this is a very small value, if the LED toggles, you will not be able to see the value. So what happens? The counter gets incremented, and when the counter gets value of 76, then only it gets the toggling of the LED. Okay, so meaning what? The interrupt is happening. The interrupt is happening, but when the interrupt happens for 76 times, then only the toggling is happening. Okay, so if the C value is too high, then also you can accommodate it by using this type of method. Now, after the timer, one more thing is important, that is counter. And eventually timer and counter are not separate. Okay, a counter is a device that keeps count the number of times a particular event occurred. It can be used to count the events happening outside the microcontroller. Okay, how many external events are happening, how many people are entering the room. Okay, so those things can be counted by using the counter. The same timer module can work as a counter module. So what is the difference between the timer and counter? For timer, the register is incremented for every clock. Whenever a clock is coming, the register is getting incremented. But for counter, that is not happening. Okay, for counter, the register is incremented if any event means what? Low to high or high to low happens to a particular pin. So when that will happen? That will happen only when a person enters the room, okay, or it will happen only when a particular event has been occurred. So that is not known to us that when it will happen. But for timer, the register is incremented for every clock, and for counter, the register is incremented only if a particular event has happened or not. So timers are used to create delays, whereas counters are used to count the external events. In this picture, we can see the same device, that is the counter register we have, and before that we have a multiplexer, 2:1 multiplexer. If I give 0 to this select line, then counter is selected. Why? Because this oscillator line is going over here, and with each and every clock, this register value is getting incremented or decremented. Now if we use the value of 1 in this select line, then this external source is selected, and whenever an event happens over here, then only the counter register gets incremented. Okay, so then it works as a counter, otherwise it works as a timer. Hope it was easy to understand. Thank you.